We will continue. No, you couldn't start one note the last time. You should try this first. Start normally. Okay, and then we talked about pi. Pi is circumference over diameter. Pi stuff. Irrational numbers. Don't fit here. All right. See if this works. It won't. So we talked about pi. There are an infinite amount of other irrational numbers. And they are, for our purposes, they are the square roots of any number that aren't perfect. Okay? So what do I mean by that? What is a perfect square? Pardon me? Each side's equal. So there's a bunch of easy ones, right? What's the square root of 4? 2. What's the square root of 9? 3. Square root of 16? 4. Everybody cool? Now, everything in between there, 4, 9, 16, the square roots of these guys, all the square roots in red, these guys are irrational. Okay? Anytime you hit square root on your calculator and it comes out to a bunch of decimals, you can fairly obviously make the assumption that it is an irrational number. Everybody cool? All right. Now, sometimes you'll get a weird situation. For example, the square root of 20.25. You don't consider that a perfect square, do you? Right? Because it's not 4, 9, 16. But if you try to take the square root of 20.25, you'll notice that it is indeed a perfect square because its square root is rational. How do you know that's rational? The decimal ended. Is everybody cool? Okay. So we're going to spend a lot of time, 4.5. So it's rational. But the square root of 20.26 would be irrational. Is everybody good? Yeah? Okay. That's all I want to talk about. You know what? I do want to do one more thing. I filled up a little bit too much of your screen, though, I think. You guys We'll do it on another piece of paper that has some more room. Okay. I want for you guys to do the A and C. No, we'll just do it. Convert this to a fraction. Who remembers how to do it? A is a pretty easy one. Who can convert that to a fraction? Holy crap. My computer power cord is all wrapped around the leg of my chair. That would be bad. Although the way the computer is behaving, it wouldn't be that bad. How do I turn 0.12 into a fraction? Nobody? Nobody remembers how to do that? Going once. Going twice. Third and final. Cassie? Yes, it is just 12 over 100. That's exactly right. Why did it take third and final to get to there? This is 12 over 100. Can we leave it like that? You can simplify it. You could write it as 6 over 50. Can we leave it like that? Three over 25. All those are the same things. Everyone cool with that? Okay. Let's look at B, because B is slightly different. Have a look at B. What does that little line mean? That it's 0.11111 for how long? Forever. Excellent. How do I turn that into a fraction? Does anybody know? Okay, well, let's talk about what we do know about numbers. If it was 0.1, what would it be? 1 over 10. Everyone agrees? Is 0.111111 more or less than 0.1? More. So the fraction must be slightly bigger than 1/10, yes? So what is, now, if it's a rational number, and is it rational? Is 0.1 repeating rational? Look at your definition of rational numbers from the page from like 3 seconds ago. Is 0.1 repeating rational? Yes. Which means we must be able to make a fraction out of it, yes? Which means it must be A over B, and those must be integers, right? Now, you guys are smart kids. The 12 became the denominator, yeah? So what must become the denominator here? 1. So I need a the numerator must be 1. What? I need a denominator. I know it can't be 10 because this is slightly more than 10, isn't it? Right? So it can't be 10. I also know it has to be an integer. So I know it has to be an integer close to 10. What are the two integers closest to 10? 11 and 9. Which one of those would make a fraction bigger than 1/10? 1/11 is bigger than 1/10? 1/9 is bigger than 1/10. Fractions go the other way, don't they? Like a quarter is smaller than a half. Is everybody good? So this, what's our guess? 1/9 is a good guess, based on what we know about numbers, yes? Well, let's check. What is 1 divided by 9? We did it! You're so smart! If something happens once in math, how often does it happen? So what is a statement that you can make about this situation? If I have a repeating number, what does that do to the numerator or the denominator? Well, let's see. Do I have a repeating number here? So what do you think this is as a fraction? 2 over what? 9. Why? Why did you make that guess, Abresia? Because it worked up here, so why wouldn't it work down here? Right? And if you check, what's 2 divided by 9? 2, 2, 2, 2, 2, 2, 2, 2. There used to be a pizza place in Vancouver called Pizza 222. That was their phone number. 222 2222. And then they invented this pizza box that was double stack. So you got one pizza box that was double decker, and one pizza was on the bottom, and then there was just a stand to hold the second pizza. So there was less garbage. Pretty cool, hey? It wasn't very good pizza, but it was easy to remember the number. Okay, so everyone's cool with that? Yeah? Everyone is good with that? Now, what do you think this is as a fraction? Because look closely at it. Only the 4 repeats. So, what is your guess? Talk to your neighbor, see if you can figure out what do you think is your estimate here. What do you think is that decimal? Some of you might know this trick already. You had a math teacher that was nerdy like me and is like, numbers, I love them. Who would like to offer a guess? Anybody? Don't be wusses. John Wong. Pardon me? 14 over 19? 49 over what? 90. Anybody want to check? That absolutely does work. So, how many of you think that maybe there's a trick here? Or has John Wong just memorized every single possible combination of repeating fractions? You know it's not the second one, right? You guys are aware of this, yeah? He has a trick. Okay. John Wong, what's your trick? What did you do to know that? Because you're exactly right. What did you use? So he's saying, well, 90 has to go on the bottom because there's one repeating number. So we know there needs to be a 9 on the bottom, right? Now up here, it was one repeating number. So we left it as 9. But this one has 2, right? So just like in place value, ones, tens, we add a 0, right? So we're adding a 0 to cover the 9 plus this guy. Everybody cool there? All right, now what? Right. You do what you have, 54 minus 5. And you get 49 over 90. What? The whole decimal minus what isn't repeating. Okay? What if it was this? Do you think? 0.154 and only the 4 repeats. Now what would it be? What would it be over? 900. And what would the numerator be? Well, we did 54 minus 5, so now we're doing 154 minus 15. 139. Everybody cool with that? Kind of useless, but I like it because it's fun. Because I'm nerdy math guy. Numbers. Everybody good? All right, now let's do some actual stuff with it. I just throw that one in there for fun. What do you think this guy is? Remember, you have 5 choices. Natural, whole, integer, rational, irrational. What do you think A is? It's a cube root of negative 14. Do you think negative 14 has a cube root? Let's think to ourselves. Are there three numbers that can multiply together by themselves to make 14? 1 times 1 times 1, 1. 2 times 2 times 2, 8. 3 times 3 times 3, 27. So it's got to be something between 2 and 3, right? What did I say about the roots between there? What are they usually? Irrational. So, what's our guess here? Irrational. So we're guessing it's irrational. How do we check? We can check it with our calculator, but finding a third root with our calculator is a little hard. A lot of people, it depends on the calculator. Some of your calculators have a third root button. It looks like that. How many people have that button? It might be like a shift tan. It might be a shift button. How many people can find that on their calculator? Oh my God, is this the first time ever that everybody in the classroom has it and I only have to show one thing? It's like Christmas. You all have the cube root button? Oh, so good. So, depending on how your machine works, if it's forward or backwards, right? If it's forwards, you're going to hit that button, then negative 14, and probably equals. If it's backwards, you're going to hit negative 14, then the cube root button. And you may or may not need to hit equals. And what happens when you do such a thingy? Second. No, not second. Math. No, not math. Where is it? Clear. Math. So for me, there's my cube root button. Cube root, negative 14. Fills up. Now, have a look at that. What's your immediate guess when the screen fills up? Irrational. But please notice what happens at the very end there. What's happening right here? That's another 4. What might happen? The next number might be 1. Do we know? Or the next number might be 2. Do we know? No. So what can we, with the technology we have right now, say for sure that this is an irrational number? Can we say it for sure? No, we can't. But it's a pretty darn good guess, isn't it? Because 2 cubed is 8, 3 cubed is 27. Everybody with me? So we're going to go with irrational. Now, look at the next one. What is it? You shouldn't need your calculator to tell me the square root of 25. It's 5, right? So what of our 5 choices does that fit into? Is it rational? Is it a decimal that ends or repeats? Yes. So it is rational. Is it an integer? Is it a positive or a negative number with no decimals or fractions? Yes. Is it a natural or a whole number? Is it positive? No decimals or fractions. So it's a whole number. Is it a natural number? Is it one we hit when we start counting? Yep. So this is what I want to make you aware of. The lowest one it fits covers everything above it. Okay? Do you understand what I mean? If it's natural, it's automatically everything else. Everybody cool? All right. So let's look at this next one. It's a trick. Somebody always gets this one wrong. What categories does C fit into? I'm the alligator in Peter Pan. It is rational. How many people wanted to say irrational? Be honest. Right? We're learning right now, so it's okay to say that. How many people wanted to say irrational? 2 people put their hands up. But you changed your mind? Oh, Mark was even going to go irrational. What makes it appear irrational? So many decimals and they don't repeat, do they? But what happens right here? It ends. So this, as a fraction, is 319,754 over 1 million. Is that a fraction? Are those both integers? Is the denominator 0? So that means that is rational. Everybody cool? Okay. What about the next one? You're going to have to think about that. You're going to have to cast your minds back to the 9th grade because we haven't done much exponents this year. We're going to do a ton of exponents soon, but that's like grade 9 exponents. It's a natural. And once you know it's natural, what else does it fit into? All of them. Right? What about 9? Same thing, yeah? What about F? Pardon? It is impossible. Doesn't exist. Why? Two negatives multiply, you get a positive, don't you? Right? 2 positives multiply, you get a positive. What's the only way to get a negative? Multiply a positive and a negative. But a square root says they've got to be both the same, don't they? So negative 2 and positive 2 is the only way to multiply to get negative 4, isn't it? But are negative 2 and positive 2 the same thing? No. So this doesn't exist. Exist in the real number system. I'm going to be lazy and I'm going to use what that symbol used to mean, which was number. Now, for some reason, it's become hashtag. I don't know why. Well, the pound sign, yes, but in writing, it means number. It doesn't exist in the real number system, but it does exist in the imaginary number system, which you guys don't have to worry about. Now, you guys are smart kids. I left this big white space over here beside this square root thing, right? Why would I leave that white space there? I didn't. You guys don't have this big white space? Your G is up here? Yep. Son of a B! Do you have white space below the F? Okay. Pretend this white space was below the F. Everybody cool? All right. Now, what is the cube root of -8? Would that exist? What would it be? Now, Mark went right to his calculator. Some of you said it was -2. Why? Because -2, -2, -2 will get me to -8, won't it? Everybody with me? So this guy is an integer. So the reason I put this here and I bring it up now is because a bunch of you heard root sign negative doesn't exist, and then you stopped listening. But you need to be aware that they do indeed exist, but it's just not square roots. Everybody cool? Yeah? Okay, now this next one is you guys. Rational, irrational. Why? Is it a guarantee? What do those dots mean? Are those dots the same as a line? Yeah, the dots just mean something's following. So this is rational, but it only appears to be. Does everybody understand? Because what might the next number be?
7.
Could be a 7. Could be a 2. It could be 1-5, which would be 1-5, not 15. But fair enough. They're single digits now, Cassie. You said 15? Antonio said just like when I make a mistake up here, Antonio, it's just to see if you guys were paying attention. I like the way you work. All right, is everybody cool? It's pretty easy, yeah? Okay. I want for you then to have a look at page 211 in your textbook. Right there.